the pad and it should be everybody in the world. Now then, crew, and welcome back to the Andy Mechanic YouTube channel. The time has finally come to take another look at Alan's CB750 made by Honda, and this is the K2 variety or flavour, whichever you prefer to say. Now, we did look at the ignition system right in the early days, a long time ago when I first started this project, and it feels like a very long time ago, to be honest. Sorry, Alan. We found that the spark was pretty weak, and I can't remember whether I did it on camera or not, but there was a bit of a volt drop in the ignition system in the primary circuit within the loom, and I wasn't particularly happy with it. Now, the plan of attack, because the bike, when we try and start it from cold, number 2 cylinder doesn't fire up immediately. It's a little bit down on compression. I think it's just a valve that's not seating right, maybe a little bit corroded on the valve seat, because the bike has been parked for a very long time. Hopefully, if we can upgrade the ignition system, get a better spark, it will start on number 2 cylinder and it'll join all its buddies right from the start, you know, rather than sort of wait until the engine's sort of started to warm up a little bit. Now, to do this, sure, you can go out and you can spend a ton of money on new ignition components, and we've done that. And we've got here some really nice Dana ignition coils. We've got 2 of those, obviously, because it's a 4-cylinder engine and a wasted spark system. So there's 2 of these, and these are the 3 ohm vintage. Okay, these are the 3 ohm spec ones, as listed for this bike. I've been discussing with the Dana Tech technical team over in the States regarding these parts, and they've been extremely helpful. So we've got those 2 new ignition coils, and I'm told that they are really good, not just from Dana either. We've also got, here we go, an electronic ignition system. There we are, look at that. And they're not a sponsor. We've paid full whack for this kind of stuff, and it wasn't cheap, believe me. So thank you, Alan, for allowing me to buy this stuff for you. Obviously, Alan pays for all this, not me. I just do the repairs, you know. So we've got all the stuff we need, but realistically, we're not doing the best job if we just bolt that on, and it's utilizing a circuit which is already compromised. It's nearly 50 years old, is most of the wiring, the connectors on that bike, and you know, and there might be a few bodges in there as well. We just don't know who's had the bike before and what's been done. And I'm just not happy, you know, with the state of play as regards the ignition system at the moment. So, first thing we need to do is look at a wiring diagram. Unfortunately, we've got one. It's pretty old school. Back in those days when they drew a wiring diagram, it wasn't really as neat and tidy and as easy to read as a modern day wiring diagram you'd find from, you know, from Honda on one of their new bikes. But we'll bumble our way through. We'll try and work it out, and then I'll simplify it on a single sheet of paper, just drawing out the ignition system wiring circuit. And then once that's done, we'll head over to the bike and we'll do a few voltage drop tests, because at the end of the day, the lower the supplied voltage to the input of the primary winding on each of the 2 ignition coils, then, you know, the lower that voltage is, the weaker the spark is going to be. Now, sure, these are good coils. They should give us a really, really crisp spark, but we need to feed them as much power as possible. And if there are points of high resistance in that circuit, they're not going to be performing at their optimum rate, which sort of, well, it doesn't make a mockery of what we've spent, but we're not making full use of spending all that money. I want this bike to fire up as soon as that engine starts to turn on for all 4 cylinders. That will make me happy. When it's cold, by the way, as well. First morning, cold start, press the fire button, chokes on, straight up. It wants to be like that. That's how I have my bikes, and that's how I want this bike to be for Alan. So let's take a look at let's take a sneaky peek at the Honda wiring diagram, and then we'll go from there. Here we go. So there you go. That is the wiring diagram. You can see we've got one of the ignition coils down here. That does cylinders 2 and number 3. And we've got the other ignition coil up here, which does cylinders number 1 and 4. And it's a wasted spark system, which means that both spark plugs fire at the same time for those 2 cylinders. So you basically get twice as many sparks as you really need. So there is a bit of a waste going on. Wasting energy, that's for sure. Okay, so if we first of all just zoom in. Come on, you can do it, Mr. Laptop. There we go. Just going to zoom in. Let's get rid of that. What the hell that means. Go away. Right, there we go, look. So, ignition coil. And it's pretty rudimentary diagram, but it's good enough for us. We've got the secondary winding is the top one there, look, and the primary winding is this one here. And the primary winding has 2 wires coming out, and if we follow that back, it's a bit slow today, is the old laptop. We've got, on the coil that does cylinders 2 and 3, we've got a yellow wire and a black with a white tracer. Hopefully you can see that okay. Now, the black with the white tracer is the power feed in, and the yellow will go across and down to the ignition points. So if we follow that yellow wire, it comes down here, look, and across. Sorry about the quality, it's not the best. It really isn't, but we'll keep scrolling down. There we go, look. So the yellow comes up here, along here, and it arrives at the ignition points and the condenser, and they're wired in parallel. And then it goes down to ground. So when the points are closed, we have current flow going through that primary winding, and when we want a spark, the points will open. The points there, look, they'll open, and the magnetic field around that primary winding will then collapse because there's no more current flow. And when it collapses, it induces a voltage, a much higher voltage, into the secondary winding because there's a lot more turns on that winding, and that's how we get our spark. Obviously, the voltage wants to go to ground or to earth, and that's why, you know, it jumps across the electrode, because essentially one side of the electrode is earth and the other side comes from the secondary winding. Anyway, enough about that. So what we're interested in realistically is the circuitry on the primary winding, the wires basically. So we've got the power feed, which we said was the black with the white tracer. So first of all, and we've got to look at the whole wiring, you know, the whole wiring circuit to look for volt drops. But we've got that runs around here, look, and it comes round and it joins a double connector here, which is the one, that's the connector right by the ignition coils. So don't be fooled by the long length of the line on the diagram. That's completely irrelevant. That connector is actually only about 1 inch or 2 inches away from the actual ignition coil. From there, we have, again, a single wire, and the other one comes from the other ignition coil, so you can see it all teased together. And it comes down here, and it goes along, and this is where it gets a little bit hard to see. So we've got the black with the white coming down here. It goes along, it's the bottom line on this section here, and it comes down through another connector, which is probably in the headlight somewhere, and it comes down, and it goes to what Honda call the ignition switch. It's not really, it's actually the kill switch, but things get lost in translation sometimes. And all that does is basically, when the kill switch is in the on position, so you want the engine to run, it connects these 2 wires together, so it goes closed circuit. Now, the other coloured wire is, what is it? Let's have a look. It's just black, that's right. Oh look, Andy Mechanic, love your show, mate. You need a viral video and you're set. Subs, what a good bloke. That wasn't planned. It's amazing what comes in, isn't it? So, Honda have their black wire as a positive. Wow, that's weird, isn't it? Most motorcycles, a black wire would be battery negative, for example. So it's easy to see how things can trick you if you don't look at the wiring diagram. So that black wire comes up, and again, it gets a little bit messy up here because this is old school wiring diagram, and it goes into this connector here. Now this connector here has got 4 wires, one of which is arriving in, and one of them, from memory, where does it go? goes down here. That's right, because I did look at this a bit earlier on, because it's very hard to read sometimes, especially with my eyesight. Comes down here, comes down, and it goes into this block here. Now what they call that is the starter button, the lighting and the dimmer switch. And then we also have another one. So that's on the actual handlebars. And we have another one here. Where is it again? It comes out. That's right there. Look, it comes out the back and it tees off there. And it comes down into the combination switch, which is actually the ignition switch. So as you can see, it's a little bit complicated to work it out. But inside that ignition switch, you can see we've got a battery terminal, BAT, just there, look. And we've got our black wire coming in, which is highlighted IG for ignition. And obviously when you turn the key, it connects those two together. So if we now follow the red wire, it comes up through another connector block, another point of possible resistance. And it goes up here, look. And then, if I just bring that down a bit, thank the Lord for touchscreen. It goes along here, it keeps going, and it comes down and across and down. Jeez. And it comes along. Hopefully I'm following the right wire now, because it's quite a long way to go. Down here. There we go, look. There's our red, and it goes to a 15 amp fuse. And if you look really carefully, there's a wire comes out, and it connects this big thick wire here, which is battery positive. So that's how they used to draw it back then. It's you don't see this kind of wiring diagram nowadays, believe me. So that's the end of the journey. We've gone all the way from the ground side of the ignition points, through the points and condenser, all the way up to the primary winding. We've gone through the primary winding, and we've followed the feedback all the way through the kill switch, through the ignition switch, and back to the battery. So what I need to do now, just to make life a bit easier for myself, so I'm not constantly looking at this diagram because it's a nightmare, is to draw it out. And then once we've done that, we can go and do some testing, and we can make a note on the diagram of the volt drops. Right, we've got a bit of cardboard, and we're going to draw out very simply the circuitry as it's detailed in that Honda diagram. But I'm going to try and make it as simple as I can, and also spread things out a bit so we can put some readings on the sheet a bit later on. So our ignition coil, we'll start off there, somewhere in the middle. And we want the primary winding in there, look. And that's the negative side, and that's the positive feed in. Not worried about the secondary winding whatsoever, no need to draw that on there. And we're going to come out and come all the way down here. And we've got the ignition points. Now they're wired in parallel, and just as per the design on the wiring diagram, we'll just replicate that. Those are the points, and this is the condenser. There you go, look. And they come down, and they then go to ground through the engine casing. Now, the ignition coil is fed from the kill switch, so we'll draw that just here, look. This is mounted on the handlebars, and when it's in the on position, it's closed circuit. Okay, the switch is closed. So that's the kill switch. And then following on, we've got the ignition switch, which is here. We'll draw it round because it is round. And there's numbers of contacts in there, but we're only interested in two. One is the ignition, and one is the battery. And then from there, that comes out, it goes to a fuse, and then from the fuse it comes down and it goes to the battery. I'll draw the battery in black. Big battery, there we go, look. Negative, positive. Right. And of course, from the battery, it goes down to the engine casing, actually, is where the earth lead goes. And that basically is the circuit. Now, there's a number of connectors on here. I'm not going to draw in yet the positions of where we're doing the testing, because things can vary. We might mix it up a little bit as we go along. We might find more points to test than I originally anticipate. So we'll do that, we'll make a start, and we're going to start off at battery positive, and we're going to find a point that's easy to get to on our way around this circuit. And the essence of this is obviously whatever battery voltage is, and we don't know what that is yet, we'll go and measure that first. That voltage will dissipate around this circuit. Now, in an ideal world, we want it to be 0 volt drop through the entire circuit except for the consumer, which is the ignition coil. So, you know, ideally 0 volt drop all the way here to the start, to the input of the coil, and then here would be 0 volt drop as well for the remainder. That isn't going to be the case. We don't live in a real world, in an ideal world. We live in the real world, and there's going to be, you know, every component within this whole circuit is a resistor, whether it's a bit of wire or a connector or a switch or a set of points or whatever it is. There's always going to be some, although hopefully very small, resistance around that circuit. And what we're going to do is test to see, you know, the condition of this, and if there's any particular points of high resistance along the circuit that we can fix, because we need to get maximum voltage through the primary winding of the ignition coil to give us the best possible spark that we can hope for. Right, let's head over to the battery and start our tests. Just a very quick run through of the rig that we've got set up so that you know. We've got a voltmeter permanently attached to the battery, and it's showing 12.93 volts, DC obviously at the moment. And we've got a little power supply rigged up to try and maintain that voltage during the testing, because obviously an ignition circuit, the coils, which are up here, they're quite warm, they've already been on for a little bit, and they consume quite a bit of current. We're measuring the current actually on those coils a bit later on. So I've extended the leads off the bike with some heavy cables. This is the ground, that would normally go straight to battery negative. We've got this additional lead which is of good quality, nice and thick, no volt drops there really to speak of, and that comes down to battery negative. Now battery positive, that comes off the solenoid, the wire there, look, it feeds the solenoid, that comes down again. We've got another connector here, which again, this is a much larger grade cable actually. It's almost like a winch cable or a starter cable for a car. That runs down and again connects to battery positive. So I don't really envisage this contributing anything really to any volt drop in the circuit, but we will include it in the measurements just to double check. So let's have a quick look and see what's easy to get to. Well, obviously battery positive is easy to get to, we can do that. And the first available point to get to, if we go down here, look, it comes out. Fuse holder, there we go, and we've got a bit of exposed wiring, fantastic. So we're going to use that, and we're going to plug in our negative test lead on there, and our positive test lead onto battery positive, and we'll see what we get. Right, we've got to be quick because Mrs. Mechanic wants to go out today, so we'll turn that to 20 volts DC. We've got our positive on the positive post of the battery, and we're going to test the volt drop in the wiring between battery positive and the input of the fuse holder. Let's see what we get. Oh, that's not bad. 0.01. And we want it to be as low as possible, don't we? So 0.01. Let's go and put that on our diagram and mark where we're up to. Hokely dokely. Okay, so we went between battery positive, so we'll call that point A, and we got as far as the input to the fuse holder, so we'll kind of call this point B. So A to B, we've got 0.01 volts drop. Cool. Make a note of that. Right, now the next one to do is across the fuse itself. So we're going to need another point here where it just comes out of the fuse holder. Can't write with my left hand, useless. And we're going to call that point C. Right, let's go and test that. Now, I just want to add at this point in time, you may be thinking, Andy, this is a terrible, terrible thing to do, to stick your probe through the wire like that. It is, but just bear with me. All of this wiring is going to get replaced. The whole lot. New fuse holder, new wiring in the loom, everything. So this is just to see, to ascertain what the current condition of the system is, to see really how bad it was before we replace it all. So we're just going to go across the fuse holder now, so we can just go into that bit of exposed I think yep, there we are. Look, a bit of exposed wire. And across the fuse holder, we have got 0.02 of a volt drop. That's not too bad, is it? Okay, let's go and stick that on our sheet. Right, trying to work around the camera. So between B and C, we had 0.02 of a volt drop. Cool, okay. So, my drawing's terrible, isn't it? It's not relative to the distance of the wiring as the diagram. So we've got here the wiring that goes from the fuse holder, basically C, to the up to the ignition switch itself. So we're going to mark on there, another mark there, D, and we're going to go and measure between C and D. This length of wire here, what's the volt drop of that piece of wire within the loom? Now remember, obviously we've got the ignition turned on at the moment, and we've got current flow going through this circuit, as it would do under normal use. You've got to have current flow to be able to measure volt drop. Just need to clarify that. Okay, so C to D. Now, obviously, the ignition switch is here on the side of the bike, and it's currently still turned on. And whilst I'm working on the bike, I'll just turn it off. There we go. Now, looking at the wiring at the back, and I've just noticed this, there's a big bundle of connectors. So maybe at some point this ignition switch has been changed, which is most likely. I mean, they do wear out, and it is a very old bike. So let's undo this clamp and get the ignition switch pulled away from the frame and take a closer look at that wiring, because that looks a bit suspect to me. Right, looks like a 13, I think. Try that. Oh, it is. I don't think Honda used 13mm bolts. So again, it's a non-standard bolt. I do like this kind of stuff. Finding problems in wiring. Yeah, that doesn't look like a Honda bolt to me. It probably wouldn't have threads all the way, and yeah. Okay, let's see if we can sneak that out from behind where the coil is. A bit of a tight fit, but we'll see. Hey, what's that? Oh, a little spacer collar, look. Let's not lose that. Okay, we'll have to spread the bracket a little bit. Oh, there we go. Oh, there we are, look. Right. Easier said than done, to be fair. Okay, so we're going to pull the loom out a little bit. And the whole thing's sort of twisted up, isn't it? Let's see if we can get the ignition barrel taken out of the bracket so we can thread it through and get some more room to work. Alan's going to go mental. Sorry, Alan. There we are. Wasn't too tight, fortunately. Right, get rid of that. I'll stick that back on there just so I don't lose it. There we go. Now we're going to thread that through that gap. Somebody's done a really tidy job of fitting this aftermarket switch, maybe. Maybe it's aftermarket, I don't know. Okay, there we go, look. We've got the prize. We've got what we need. Need to have a little look inside here. So, where's the end? There he is. Let's have a look. Let's see what's going on. Because this is exactly the kind of thing we should be trying to... Oh, no. Really? Now, this wasn't Alan. I'm not going to tar Alan with doing this kind of stuff, because, in all honesty, he really wouldn't get involved with changing ignition switches and stuff. It was probably done when he bought the bike, to be fair. And unbeknown to him, somebody has butchered this bike. We call these chocolate blocks in the UK. See if we can get some more of this terrible insulation off. All this needs tidying up. It really does. I'm going to find my knife. Oh, don't draw blood. Don't draw blood. Okay. fact, while I'm doing this and getting this tape taken off, why don't you have a little listen to what Tool Girl Holly has to say.
Hey guys, it's Tool Girl Holly here. Now's the time to grab your anti-mechanic mug. You can find that on the Zazzle website, just up the top here. Once you do, you can take a selfie with it and send it to antimechanic@live.co.uk. That'll throw you in the draw to win some really cool stuff, including forge gear, ting tools, and the anti-mechanic personalised jacket. Draw will be drawn on December 2020. Signing off, Tool Girl Holly.
Oh no. Oh no, that just fell off. Oh man, that must be off that one there. Oh, yes, it is. Okay, so we had a very bad connection there, and only an inch away there are some more connections. Why would you do that? Holy moly. There we go. Right. So I'm going to have to tidy that up and stick that back in. I don't think it's going to affect our test too much, because what we're interested in is that red wire and the black wire. That's right, because the black wire goes off to the kill switch. So it's those two wires that we're bothered about. So let's get our multimeter, turn the ignition back on. So we'll stick the key back in. Sorry if I'm a bit off camera there. There we go. Come on, key. Is that the right key? That's the wrong key. That's the right key. Right. Ignition is on. Trying to short anything out. Okay. Meter back on again. 20 volts DC. Now, what a state this ignition barrel's in. Or the wiring, should I say, to the ignition barrel. The two wires we're interested in. This is the input, the red wire coming in. There's already some damage or repairs done back here. Then we've got a chocolate block, then it goes in through the switch gear, and then it'll come out on this black wire, and it's going to go off to the kill switch, basically. So we're interested in the volt drop on this wire through the loom, the red wire, and the positive probe is on the output of the fuse holder, which was C, wasn't it, on the diagram? So we're going to go straight in there, and we're going to measure the volt drop. And we've got 0.05. That's getting up there, isn't it? Okay, 0.05. Let's go and stick that on the diagram. Right, so C to D, 0.05 volts. Wow, drop. Okay, so now we know, and now we've pulled all that wreckage, the tape and everything off the bodged wiring to do with the ignition switch. We can also take a reading here just as it comes out of the ignition switch on that black wire, so we'll call that point E. So now we're going to measure the volt drop through the ignition switch itself. And remember, ignition switches are a wearing component. The switch gear in there is turning on and off, and we've got a reasonable current flow going through there, so there's going to be some arcing as well every time it's turned on and off, it's going to wear the contacts. So I'm expecting to see something a little bit higher than what we've had previously. Let's go and measure that. Right, meter on. Can you see the meter? You can. There you go. Look, not too much glare on the screen. Right, so the red probe now, the positive probe, will go on where we had the negative previously. So it'll go on there, on the way in. And we're going to put the negative probe on the exit point. Trying to get a good connection there. Oh wow. 0.19 volts dropped just in the ignition switch alone. Jeez. Okay, let's go and stick that on the chart. Actually, just for clarification, let's just double check that that's not in the chocolate block itself. So we can take exactly the same reading on the other side of the chocolate block. And we can do it on this side here on the output of the chocolate block. We call these chocolate blocks in England, by the way. So we've got positive on there, negative on this side. Exactly the same reading. Okay, so the chocolate block itself isn't causing any problems. So 0.19 to go on our sheet. So either side of the ignition switch we've got, or going through the ignition switch, we've got 0.19 volt drop. That's quite high, isn't it? Obviously, less the better. Okay, so this wire now, this black wire runs up into the headlight of the bike. We've got to take the headlight off, and we'll find a connector in there, which will be black, just a black wire. So the next point we can check will be here, F. So we're going to measure the volt drop of this section of wiring from the ignition switch up to the connector inside the headlight, which then runs up to the kill switch. Right, headlight off. Don't drop the screws or the headlight, Andy. I think a headlight like this would be quite hard to replace these days, so try not to do that. We're missing a washer. Interesting. Very good. So far, so good. Okay, so let's unplug the headlights. Let's get rid of that. Well, I can't really get you any nearer, unfortunately. So I was in here a while ago, just checking out the wiring, just to get my head around it. So we've got, I've labelled these two up. We've got, here is, what's that one? That one's to the coil. So the black one here, this is the wire, got the wire coming in, just in the back here, very hard to get to. We'll have to try and go in through the back of the headlight unit to get the probe onto there. So, where's my little pointer stick? Yeah, it's always a bit of a bird's nest, this kind of wiring inside the headlights, isn't it? Always, every bike's the same, unfortunately. So, that connector there, hopefully you can see that okay, is the connector where that black wire comes in from the ignition switch, and it splits off. It does a few things. It's providing power to quite a few different circuits, one of which is the ignition circuit, and it's going out on this black wire. It goes off down there and it goes up to the kill switch on the handlebars, and it comes back down on this black wire with a white tracer, and this is what heads off to the ignition coil primary. So we're not too far away. It's all quite warm actually. There's definitely some current flow going on. Right, let's get the meter set up and take a reading. Okay, positive probe is now on the black wire on that chocolate block coming out, and we need to get into this connector here, look. So we're just going to pop it in there. It's a joint connector, so it should be pretty easy to get to. There we go, 0.03 on that section of wire. Cool, let's go and stick that on our chart. Right, not too bad, but it is only a short section of wire. We've got a 0.03 volt drop between point E and point F. Now, the next one is the kill switch, so we can mark that on there, point G, and that'll be that connector, again, inside the headlight with the black, which is BK/W wire. This was a black wire, and that one was a red wire. Just for reference, there we go. Okay, so across the kill switch now, so we're going to move the positive probe from E to F and apply the negative probe to point G. Oakley dokley, right, so we'll pull the negative one out. It was quite well trapped in there, wasn't it? And we'll stick the positive one in, so we can get it lodged in like we had the last one. There we go. And this is the black wire with the white tracer. Very hard to get to the connector actually. So maybe I've got to go in from the back. Just bear with me. That's that one. You're not going to see a lot on the camera, unfortunately. It's just the way it is when you're doing some testing like this. Oh, I can just see the edge of the connector. Hang on. What have we got? Oh, try again. Sometimes it's not easy. Right, so that's the multi-connector, that one, to hold that. And then, see if I can get on the end of that one. What have we got? 0. Gee, that was quite high, wasn't it? Oh, bad connection, Mr. Young, bad connection. Hang on, I'm going to stick to the original plan. Let's go in from the back, because that's not reliable enough. There we are, right up inside that connector now. What have we got? 0.14 of a volt drop in the kill switch and the wiring that runs up to the kill switch. Okay, 0.14. Let's stick it on the chart. Okay, so 0.14 of a volt drop between point F and point G. Now, ignition coil. So now that black with the white wire, white tracer, runs back from the headlight down to where the ignition coils are. So again, not a great length of wire, so we're not expecting to see a particularly high volt drop. But we'll label that one up H. And there is a connector at that point, so we can go in there. Right, I've put the positive probe where the negative one was, because that always chases us along. And we've got the negative probe here, and this is the connector which comes from the back of the headlight, where it's come down from the kill switch. It's come through the loom, and this is the bit. So we can now go into there. Wow, those coils are getting pretty hot. And we had a reading. Where did it go? There we go, look. So we've got a reading there of 0.04 of a volt drop. Let's go and stick that on the sheet. Right, so 0.04 volt drop between point G and H. Now, this is where it gets really interesting, because we're going to measure from one side of the primary winding to the other. So this is going to be point I. Now, don't forget, the ignition coil is the consumer in this circuit. That's the thing that's doing all the work. We would expect to see a massive volt drop, and the bigger the volt drop, the better for that, because it means it's getting more power. So H to I, and the output wire is yellow on the ignition coil that we're looking at. You could do it on the other one as well, which I think is green, but we'll stick to the yellow one, and that's the points that we're going to look at as we work our way down the circuit. Coolio. Right, back to the bike. Okay, we're going to pull that probe out. We're going to stick it in with the red one, because the red one always chases. I'm going to stick it in there. Hopefully we'll get a good contact. Try and get it trapped between the outer and the metal. And the yellow is basically the output. So the black with the white tracer is the input into the primary winding of that coil, the far coil in the picture. And this is the output, and this wire, the yellow wire, goes down to the ignition points, and then it's grounded, and that completes the circuit, you know, when the points are closed. So let's turn our meter on. Let's see if we can sneak in there and get a reading. Now remember, this is going to be really quite high. We want to take the highest reading we get. So we've got 12.34, and just for reference, battery voltage is 12.86 at the moment. So 12.34 to go on our diagram. Right, 12.34 volts, and that's a drop. That's actually pretty damn good. It's a lot higher than I was expecting it to be. But don't forget, our batteries now are currently running at about 12.9. Okay, so we're just going to stick that in a box. It highlights it. There we go. And, well, where are we going to do our next one? Okay, well, obviously we'll move the positive probe to I, and then we're going to have to dig down There we go, look, dig down to the points side of things. So basically where that yellow wire comes onto the points, we can do a check to see what the condition of this particular section of wires like. Now, the ignition points are housed inside this little tin cover on the right hand side end of the crankshaft. So we'll just whiz our way in there. One of the threads is a bit dodgy, I think it's the bottom one. Because we have been in here before. There we go, look. Not a lot of threads left in there. In fact, somebody's... that's got some like plastic metal in it, hasn't it? That's obviously been bodged in the past. Maybe the bike's been dropped at some point and it's been broken off. I don't know. Okay, so we've got two sets of points. One set of points doing each ignition coil. We're working on the yellow wire, and you can see here, look, the yellow wire is coming in and it's feeding this set of points. So this set of points is basically grounding the right hand ignition coil on this bike, and which is doing, what are we doing, cylinders 2 and 3, and this set of points is grounding the left hand ignition coil, which is doing cylinders 1 and 4, and it's a wasted spark system, don't forget. Right, let's get set up with the meter and take some readings. Right, so we've got the yellow wire coming down from the output of the primary winding, running through the loom here, and it joins onto the points. And the same position is where that condenser connects as well. So they're wired in parallel. So we can stick our meter just up on there, and we've got the positive probe is currently in the connector of that yellow wire. So we're testing the volt drop from that connector down to this position here, just before the ignition points. So what have we got? Wow. Hey, that's not good. If we go onto there, look. Yep, so it's actually on the connector itself. 0.17 on the bolt. 0.17. Okay, right, let's stick that down on our sheet. Okay, so we're going to mark that as HIJ. That's going to be position J, and we had 0.17 volts drop. And that's not that long a length of wire either, so we've definitely got an issue going on with the wiring between the output of the coil primary on that particular ignition coil coming down to the ignition points. Right, okay, so the next step is to check what the resistance is, sorry, not the resistance, the volt drop across the points, because I know that the points surface is quite badly pitted at the moment. They're pretty burnt, so we can measure that, and then we can also measure the ground side of the circuit. So we can just take it straight from the backing plate of the actual points where they're mounted onto, where are we? There we are, look. Onto, running out of bench, onto battery negative. Right, let's go and do that. Okay, to check across the points, we just chase it with the red lead onto where we were before with the black. We'll stick it on there, go down to the ground plate. 12.39. Hey, that's not good. That means the points aren't actually making contact. Well, they were earlier on, we know that. So, if I just bridge it with that, you can see, very quick check. If you just bridge the points and you get a spark, then you know full well that those points are actually not making contact at all. So, in the interest of science, let's just adjust those a little bit and see if we can close the points up. So it's that one there actually, number 3 Allen key. These are going to get replaced anyway, by the way, so we don't need to worry too much. So hopefully that's going to give it enough. Can we see them arc when I open it up now? We can. Perfect. Okay, so back to the original test. Positive on there, that to ground, and we've got a volt drop of 0.36 across the points. That's really high, isn't it? 0.36. Back to the bench. Okay, so that's going to be point K, which is essentially there, look, approximately 0.36 volt drop across the points. That's terrible. They're supposed to be contact break, you know, they are contact breakers. They're supposed to be, you know, low resistance. Okay, what we've got left? Well, we can also check the ground, so we can go from the same backing plate for the points straight onto battery negative. So we'll put the positive terminal here on the backing plate and the negative terminal on battery negative, and we'll see what we get with that. That should be incredibly low because we've got a nice heavy cable going from the engine casing over to battery negative. So hopefully that won't be too high. Okay, I've put the negative terminal on battery negative, and now we're just going to pop this onto that same position where we had it before. Oh yeah, look at that, we've got 0.01, that's really good, quite happy with that. Hopefully you can see that okay. There you go, 0.01, excellent stuff. So that's the last part of the circuit. Let's go and do some sums. Okay, so on that earth stretch there we had 0.01 volt drop. To complete the circuit. Oh, I need some more cardboard. There we go. Can't beat cardboard, can you? I never throw it away. Right, let's start at the beginning then, because we'll need to add all these volt drops up now. So we've got A to B, we've got 0.01, we've got B to C, 0.02, C to D is, C to D was 0.05, now D to E, D to E, oh no, that was a big one, wasn't it? 0.19, and that was the ignition switch. And right, E to F, 0.03, not too bad. F to G, kill switch, was 0.14, and then G to H was, oh, yep, 0.04. Getting confused for a second there. H to I, which obviously is the ignition coil, which is what we wanted at 12.34, and then I to J was the well, the wire down to the points, and that was 0.17, and then we've got J to K, which was the points, which was 0.36, and then we had K basically to battery negative was 0.01. So let's add all of that up, see where we end up. Right, I'll do those two in my head. 0.08, 0.08 plus 0.1, oh, go back one, 19 plus 0.03, 0.14, 0.04, obviously 12.34, which was a good reading. A bit concerned about that, to be honest. 0.17, 0.36, 0.01, 13.36. Okay, let's go and check our battery voltage. Okay, it's climbed up a little bit, so the battery's obviously charging up. 13.33 volts. So that's about bang on, to be honest. There's always going to be a little bit of a discrepancy in your readings. Super job. Right, let's go and talk about what we found. So, a simple volt drop test, and we've covered the entire circuit of that ignition system. Pretty easy to do, just got to take your time. And to be honest, working on it, I had all sorts of problems, to be honest. Some stuff that wasn't shown on camera. In fact, let me just grab something. Believe it or not, for some reason, I stopped getting a voltage, a volt drop when I was checking the yellow wire down at the points. And I took a closer look, so I traced it back, and the little connector, the little connector that goes in, the bullet connector that goes in into the right-hand ignition coil, which happened to be the one that we're actually testing, or that forms part of the circuit that we're testing, it wasn't being powered. It started to cool down. There was a distinct temperature difference between the left-hand coil and the right-hand coil. And to do these tests, I wanted both coils to be energized, which is the maximum draw on the circuit. And I gave that just a little tiny wiggle, and it bloody broke off. So as soon as I repaired it, hey presto, we're back to normal. But again, you can see, and I've already cleaned these up once. You can see on there just how much. So it's a lot cleaner now, but there's actually quite a bit of corrosion. I know you can't really see it very well, can you? It's pretty crap on the focus, unfortunately. But believe me, it's not in good condition, and the fact that the wire just snapped off the end of it, it's not going to help, is it? It's hanging in there by a couple of strands, which in itself is going to pose quite a high point of resistance. So, what did we find? Well, other than the fact the whole lot is going to get replaced, but the current state of play, other than the fact somebody's cutting the lawn as well, is points of high resistance. Well, the ignition switch, 0.2 of a volt disappearing going through the ignition switch. Kill switch, almost the same, 0.14. So again, there's burnt or damaged contacts inside the kill switch. The points themselves, a third of a volt disappearing across the contacts of the ignition points, which again isn't surprising. The point's surface is quite badly burnt and pitted. It's not making great contact, so it's a point of high resistance. So, all in all, yes, we had a supply of 13.36 volts, but the actual ignition coil primary was only being fed 12.34, which essentially is 1 volt less than what it should be getting. If this circuit was as new and in good condition, we would see much less volt drops. Sure, there would be some, but it would be negligible. A whole volt drop in the circuit is not negligible. What we haven't measured is what the voltage drops to whilst cranking. That's going to pull the voltage down significantly, and that in turn is going to weaken the spark. And what we're trying to do here is to get a nice crisp spark during crank, especially when the engine's cold. And the starter motor draws maximum current when the engine's cold because it's harder to turn over. The oil's thicker. It takes a lot more energy to get the thing to start to rotate. So at that point in time, we get the weakest possible spark. So where to go from here? What am I going to do about it? Well, I'm going to do two things. I made a decision, and I had a live stream this morning and put the idea out to a few of our regular viewers, and they came back saying that was a great idea. They sort of endorsed my plan. So what I'm going to do is replace all the wiring that we've just tested, all the connectors, the whole lot's going to get renewed. The ignition switch is probably going to get renewed as well. I can source a new one of those. I'll try and get genuine if I can, because try and keep the quality. The kill switch, I'm hoping I can take that apart and clean the contacts. And that will essentially, reduce the volt drop in that circuit tremendously. I will eventually be fitting a new electronic ignition system, but just for this particular purpose, I'm going to revisit this. Once all the new wiring's on, I'm going to fit new ignition points and new condensers. So we're going to put the bike back to original spec first, and we're going to do a spark test. And then once that's done, and we'll do some volt drop checks as well around the circuit just to see how much it's improved. Proof of concept to wrap this up. Not today, obviously, it'll be in a future video. And then we're going to convert the ignition to electronic ignition. However, there's more. I've decided to do even more. At the moment, one of the main problems is that this ignition circuit is carrying all the current to feed. It's directly feeding the primary winding, which causes problems with switches and contacts around that circuit. We can see it in the ignition switch. We can see it in the kill switch. And obviously we're going to eliminate the points. It's going to get the electronic ignition. So my plan of attack is to have this circuit just power up a simple relay. you know, one that's designed to be on all the time. Maybe I'll use something like a 30 amp relay. It's got nice big contacts and stuff in it. And then the relay will be triggered by this circuit. So when all the contacts are closed, for example, the kill switch is in the on position, the ignition is turned on, all that will do is trigger the relay, and then the load carrying side of the relay will be what will provide the ignition system its power, i.e. the new Dana ignition coils, which will draw more current because they're a heftier coil. And we should then see far less volt drop in the supply from battery voltage to those ignition coils. They should basically get more power, more of an oomph to give us an even better spark. Because I don't see the point in fitting really expensive ignition coils when the wiring that you're going to be attaching them to is essentially junk, which it really is. This is terrible. Okay, crew, well, that's the end of this video. Hopefully you found it helpful. If not, geez, I'm getting tired now. I'm in a rush because Mrs. Mechanic wants to get out on the road and go and watch some motor racing. So do I, to be fair. So, if you found the video helpful, why not click on the subscribe button? You'll see a little gear icon turn up, click on that, and then you can ring the bell, tick the box, do whatever you need to do for our friends at YouTube to send you down an email as and when I upload any new videos. And that way you won't miss out on future episodes of the CB750 K2 project and Tool Girl Holly's DR200 and lots of other stuff that's going on. And if you get bored, there's a huge archive of videos already on the channel, over 550 to be fair, which you can mooch your way through at your own time. You'll also find me on Facebook, Instagram and Twitter. Feel free to communicate through any of those portals. You can even flick me an email. My email address is down the bottom in the description. Now, if you'd like to support the channel, and you know, quite a few viewers do, and it's much appreciated, it really is. It allows me to spend a bit of money on these kind of projects and bring you these videos. Then you can do that through Patreon, and you can read all about the history of the channel on there, and the tool girls and so on. Or you can go on to PayPal and do a direct payment that way. And again, it's the same email address, andymechanic@live.co.uk. Okay, crew, I've got to get tidied up. I'll see you next time. Cheers, over and out. And you get the flip up again.
Oh!
Really.